Iodide ions I- aqueous react with MnO4- aqueous. The unbalanced equation is shown below. What is the ratio of MnO2 solid to OH- aqueous in the balanced equation? A 1 to 3, B 1 to 2, C 1 to 1, or D 3 to 2. The common mistake that was made in this question is balancing the elements, putting a 2 here and circling B. But we also need to think about the charges in this question. So doing this method is incorrect for this question, and our answer is not going to be B. So in this question, we need to think about balancing the charges as well as the elements, and we can do this using oxidation and reduction and making half equations. So if we start with our reduction half equation, we're going to have MnO4 minus, and then we're going to add water and produce MnO2 plus OH minus. So the MnO4 is changing from an oxidation state of +7 to being +4. So it's being reduced. And now we can balance. So balancing this equation, we put a 2 in front of our H2O and we put a 4 in front of our OH minus. And then because we're reducing, we need to add 3 electrons in order to balance the charges, and also reduction is the gain of electrons. Next, we can look at our oxidation half equation, and that's going to be I minus plus OH minus, and that's going to produce IO minus plus H2O. So the reason we're using OH minus is because iodide is forming iodate in basic conditions. And this is an oxidation because we're going from a -1 oxidation state to a +1 oxidation state. So we're oxidizing, we are losing electrons. So balancing this equation, we put a 2 in front of our OH minus, and we need to add 2 electrons to balance the charge overall in this equation, or this half equation. So now we've written our half equations, we can begin to form our overall balanced equation. So the first thing we need to do is scale the electrons. So we need to have 6 electrons in both because the common number between 3 and 2 is 6. So rewriting our reduction half equation, that's going to be 6 electrons plus MnO4 minus, and we need 2 of these, plus 4 H2O, and that's going to produce 2 MnO2 plus 8 OH minus. So we've multiplied everything by 2. Now rewriting our oxidation half equation, we need to multiply everything by 3. So we have 3I minus plus 6 OH minus, and that's going to produce 3 OIO minus and 3 H2Os with 6 electrons. Then we cancel out. So we're going to cancel out the electrons from each side of the equation. We can also cancel out some of the OH minuses. So we can cancel out all of these 6 and then 2 from the reduction half equation. And then cancelling out some of the waters. So we can cancel out these 3 from the oxidation half equation and then 3 from the reduction half equation, leaving us with 1 water. So rewriting this overall balanced equation, we get 3I minus plus 2 MnO4 minus plus H2O, and then this goes to 3IO minus plus 2 MnO2 plus 2OH minus. So the question's asking us about the ratio of MnO2 to OH minus. So looking at the overall balanced equation that we've now produced, we can look at the ratios. We've got a 2 and a 2. So a 2 to 2 ratio is also a 1 to 1 ratio, and that's C. So to get the mark for this question, you need to write C in the answer box provided.